Young-Davidson is an underground gold mine located near Matachewan, Ontario, about 60 kilometers west of Kirkland Lake. It is one of Canada's largest underground gold mines with a design capacity of 8,000 tons per day. A multi-year expansion of the operation was completed in July 2020. This included transitioning to brand new infrastructure in the lower mine, which is bigger, highly automated, and significantly more productive. This infrastructure is expected to increase production, lower operating costs, and combined with declining capital spending, drive strong free cash flow growth. The lower mine expansion has only started to unlock the full potential of the operation. With a large mineral reserve and resource base and significant exploration potential, Young-Davidson will be the foundation for Alamos' growth for many years. Safety is a core value of Alamos and Young-Davidson. We have a strong safety culture which aims to maintain a safe, healthy work environment for all, and we are focused on continuous improvement with ongoing training through our Home Safe Everyday program. In response to the COVID-19 pandemic, we have instituted a number of health and safety protocols, including implementing PCR testing of all personnel prior to starting their work rotation, as well as all visitors. This is a part of our commitment to help protect the health of our employees, their families, and the community. Young-Davidson Mine has two main points of access to enter the underground mining operations. It consists of a ramp system from surface to a depth of 1,500 meters and the MCM shaft, which consists of a skip cage arrangement with the ability to hoist personnel, skip waste, and send material underground to a depth of 1,500 meters below surface. The ramp system accesses the sublevels every 30 meters in the upper mine from surface to the 9410 level, and every 35 meters in the lower mine from the 9410 level to the 8920 level. The sublevels provide access to establish the development on each level to allow extraction of the ore body. The MCM shaft is a rectangular excavated shaft that is serviced by a double drum hoist equipped with 6-ton skips and cage capacity for 12 people. The MCM shaft has a hoisting capacity of 900 tons of waste per day. The second shaft on the property is the North Gate shaft. This shaft is the main production shaft and is equipped with a friction hoist to a depth of 1,500 meters below surface. The North Gate shaft is a circular shaft, 5.5 meters in diameter, and was excavated in 3 phases to its full depth. The hoisting plant is equipped with 24.5-ton skips and has a hoisting capacity of 10,000 tons per day of ore and waste. The Young-Davidson mining method is primarily transverse open stoping with delayed backfill. The development cycle consists of excavating approximately 5-meter by 5-meter drift openings. The drifts are excavated by utilizing 2 boom jumbos to drill the development rounds, 4 meters in length. The broken material from development blasting is mucked with 8-yard scoop trams to the waste pass system or ore pass system, or co-disposed into stopes for backfilling. Mechanical bolters are utilized for installation of ground support with 8 feet long bolts in the back and 6 feet long bolts installed in the walls of the excavation. Additional ground support is added with cable bolts in larger underground infrastructure that will be utilized for the life of the mine. The stope backs are also supported with cable bolts for additional support during the mining phase. The production drilling cycle utilizes ITH production drills in the stopes to drill a 30-inch diameter slot raise and a 4.5-inch diameter production hole. All the 4.5-inch production holes are loaded with an emulsion blasting product and initiated from the central blasting system on surface during shift change. Once the ore stoping blocks are blasted, the mucking cycle commences for extraction of the broken ore. The production fleet consists of 12-yard scoop trams for hauling the ore from the stopes to the ore pass located on the level. The ore pass feeds directly to the rock breaker station on the 9025 level. No further rehandling of ore is required once the ore is fed into the pass system, as the crushing and conveying system will bring the ore to the North Gate shaft for hoisting to surface. This is a significant improvement from the previously utilized upper mine infrastructure, which required ore to be rehandled multiple times. The paste backfill cycle follows once the ore has all been removed from the stoping block. A paste fill wall is first installed at the extraction level to confine the paste fill to the stope. Paste fill placement is fed from the surface plant by gravity through one of two boreholes and is distributed underground by a network of pipes on the levels and boreholes between the levels to bring paste to the desired stope for backfilling. The use of paste fill at Young Davidson provides three benefits. This includes increased mining recovery, or the amount of ore that is recovered from underground, and the faster cycling of stopes supporting higher mining rates. It also reduces the amount of tailings that would otherwise be going to our tailings facility by more than half. Before transitioning to the new lower mine infrastructure, the upper mine ore pass system delivered ore through 4 ore passes from each of the sublevels to the 9590 level. From the 9590 level, ore was loaded a second time by scoop trams into haul trucks and hauled to the ore rock breaker and dumped on a 24-inch square grizzly. After passing through the grizzly, ore was fed to the 4860 jaw crusher and crushed. The crushed ore was then fed to the loading pocket and conveyed to the skips, which had a capacity of 17.5 tons per skip, 40% smaller than the new skips being used in the lower mine. The fine ore bin capacity below the crusher was 500 tons with 1 hour of skipping inventory. The lower mine infrastructure from the 9590 level to the 9025 level are fed by 2 pass systems, the West Ore Pass and the East Ore Pass, which were excavated in 2 legs. The lower pass systems have improved designs with better alignment between the 2 legs, better geometry as they are excavated circular, and additional ground support with the shotcrete applied to the pass systems. The lower mine production from the sublevels feeds directly into the pass systems, which feed directly to the rock breaker, eliminating the second rehandling that was required in the upper mine. The pass systems in the lower mine have a transfer point at the 9305 level for the East and West Ore Pass. This allows ore flow to be fed into the system above and below 9305 and facilitates constant feeding of the system from different mining horizons. When required, the ore bypassed at the 9305 level to the pass systems below. The ore flow is controlled by a chute press frame assembly to control the flow of ore to the rock breaker. The pass systems are kept 2/3 full to ensure long-term stability of the system. The rock breaker station on the 9025 level is fed from 2 chute press frame assemblies that feed directly onto the ore grizzly panels with a 24-inch square opening. The rock breaker station is equipped with 2 breakers. Only 1 breaker is required to meet the production requirements of 8,000 tons per day. The second breaker is in place as a backup to allow for constant feed during scheduled maintenance. Once the ore passes through the rock breaker, it is fed directly to the crusher on the 8990 level. The crusher is a 4860 jaw crusher, a twin to the upper mine crusher, which has a crushing capacity of 800 tons per hour to generate -6-inch material. The crusher has excess capacity as it's only required to operate about 10 hours a day to meet the production requirement of 8,000 tons per day. Crushed ore feeds a bin directly below, which has a 2,700 ton fine ore bin capacity to the 8930 level. From the 8930 level below the crusher fine ore bin, ore is conveyed by a 60-inch wide conveyor feeding 2 ore storage bins at the 9,000 level near the North Gate shaft. The conveyor system is a significant improvement for handling compared to the upper mine, as it eliminates the higher cost of trucking, maintenance of the trucks, and ventilation requirements. The conveying system significantly reduces unit operating costs. the conveyor can deliver 725 tons per hour of ore to the two bins, which more than meets the production requirement of 8,000 tons per day of ore. The first bin has a fine ore bin capacity of 2,300 tons, and the second bin has a fine ore capacity of 1,000 tons. The total fine ore bin storage below the crusher is 6,000 tons, which provides 12 hours of skipping inventory, an increase of 11 hours of skipping inventory, and an increase of 5,500 tons of fine ore bin capacity compared to the upper mine. This effectively means no downtime between blasting and shift changes. The two fine ore bins feed the loading pocket conveyor at the 8940 level, which feed two measuring bins. Measuring bins are calibrated by the load cells to hold 24.5 tons. The north gauge shaft lower mine skip capacity of 24.5 tons represents a 40% increase over the upper mine skip capacity of 17.5 tons. The cycle time for a skip to reach the surface headframe is approximately 166 seconds. Processing at Young-Davidson consists of the underground ore crushed to a -6-inch product size. Once it reaches surface, it is conveyed to two fine ore bins and processed through an 8,000 tons per day, single-stage semi-autogenous grinding circuit followed by bulk flotation. The flotation concentrate is further ground, thickened, and leached in a conventional CIL circuit. The flotation concentrate CIL tails joins the thickened flotation tailings and are leached in a combined CIL circuit. The gold is recovered from the loaded carbon, followed by electrowinning and pouring of doré bars. Young-Davidson carbon and leached final tailings are treated with an SO2 air cyanide destruction method before sending it to the tailings facility or to the paste plant for further distribution back into the underground workings. The paste fill plant receives tailings from the milling circuit and produces the paste for mine backfill. The first step in the process is dewatering of the tailings in a thickener. This also helps to improve the slurry density to about 75% solids. The thickener underflow is directed into two separate paste production lines consisting of the following: a disc filter to further dewater the tailings, 4 binder storage and metering systems, and handling systems to deliver a binder to the paste blending system. Each binder storage and metering system may handle different blends of binder: a mixture to blend the paste hopper to feed the distribution system. The paste backfill plant was commissioned in 2014 and is capable of supplying paste fill to the underground voids at a rate of 8,000 tons per day. About 60% of the tailings material generated from processing the ore is redistributed back to the underground to fill the voids created from mining of stopes. The remaining tailings material is currently deposited into the TIA-7 tailings facility. The facility was commissioned in 2012 and will reach its capacity limit of 15 million tons by mid-2022. The second new tailings facility, TIA-1, is currently under construction and scheduled to be completed by the end of 2021. The new facility will have capacity of 25 million tons, enough for all existing mineral reserves and resources, with the potential for further expansion beyond that. Both tailings facilities are constructed with centerline dam designs, and all dams within the facilities are plastic lined, which support industry best practices for engineered tailings dams. The tailings water is recycled from the facility and pumped back to the processing plant to be reused as process water for the milling process. Young-Davidson is only just starting to show its true potential, having achieved consecutive records for mining rates in the first 2 full quarters following the completion of the lower mine expansion in July 2020. Mining rates are expected to continue to increase into the second half of 2021 to design rates of 8,000 tons per day. This is expected to drive production higher, costs lower, and combined with lower capital spending, record free cash flow of more than $100 million in 2021. With a 14-year mineral reserve life plus several years of resources beyond that, and significant exploration potential with the deposit open at depth and to the west, we expect Young-Davidson will be a strong free cash flow generator for a very long time.